See here. Alright, let me get everything set up. I just now stopped working on 4-coder code. Wait, let me look at one thing real quick. I'm curious. Wow, okay. Guess I did just auto-generate a whole new thing. That makes sense. Okay. Anyways, let's get to this. Alright, so here's the game. Haven't shown off a lot of the stuff that's happened since Monday. There's last Monday I did asset swapping, which I'll demonstrate in a minute because we're going to do more stuff with that. But in the meantime, other things that have happened include smoothing out the player's motion. I think the HUD is new now. Was not here before. Just sort of a test version of the HUD. Make sure we can see how things are going to fit on the screen and stuff like that. Make sure we have a system for putting stuff like that up there. And now, what I need to do today is I have this debug mode where I basically am able to just throw up random information, and you can see I've got the mouse coordinates up there, for instance, and I've got these boxes here and there to help me out with stuff. And those are fine. But today what I want to do is work on not exactly the debug thing, but a system kind of like this, which is going to be the F2 menu, which when I hit F2 right now, there's nothing showing up. But I'm in right now the editor mode, and there's just no editor features. And the first editor feature I want to add is I want to be able to list the assets and intentionally swap out one asset at a time. So I can say, here's the asset I'm trying to replace by having, you know, just a thing that represents the asset. And it's not totally clear exactly how I want to do, like what information I want to store with an asset. Do I want to store the file name it came with? Maybe I do. And also, you know, how does that need to be organized so that I can support things like allowing the artist to add more asteroids without me having to put in new hard-coded IDs into the IDs header? Because right now every single asset just has a hard-coded ID, but as we go, we're going to try to get away from that and actually get to having 0 hard-coded IDs and have everything be sort of stored in data files in terms of which files go to which asset IDs and how the game's objects link to asset IDs. So, since that's all going to be sort of dynamic in a data file, we need to start pushing towards how we're going to store that as a file and put it back into the game at launch. And also how the code for like making the player and making the asteroid will reference the IDs, since they don't have that hard coded. That also has to come out of a data file. So one thing at a time there. Obviously I probably won't get to all of that today, but that's everything that's sort of been on my mind recently about this game and the asset system. So what I want to do is I want to start thinking about listing out just the assets and figuring out how I'm going to store assets as in a data structure, like how I'm going to keep the information about all of the existing assets, how I'm going to keep information about the assets that are currently loaded, or if there even is a concept of loaded and not loaded, like how would I handle that? It's not right now. There's just one flat array that represents all of the assets and has all of them loaded in, and I think that I want a little more. I want a little more than that so that I can do a number of things. So let's look into that. So right now what happens is when the game starts, and you know what I should do before I get too far into this, let me just double check that everyone on the stream is happy with what they're seeing. Looks like we are sort of working. Hello folks, let me know if there's, you know, anything going on with the stream quality or something that I should fix. If you can hear me, then we're good. Alright, so what happens at the beginning of the game is I just bind images by giving a bitmap file to an ID, which is a hard-coded ID. Like I said, I want to get away from hard-coded IDs eventually, but I'm not ready to do that yet. And I want to get rid of. Well, what's going to happen is the IDs will be linked to file names in a data file. But I think what's going to happen is actually the data that the game has is going to be all one big block. The asset system will be stored in a block, and there will be the sort of the binding data and the live loaded data. And what I want to be able to do is take the binding data and just dump that to the file and load that out of the file on disk, and that way it's the same format. I don't have a file format and the loaded and the live manifest format and the loaded format. There will just be two formats: the fully loaded images and the manifest sort of system, right? And that manifest will be something that it's identical whether it's on the disk or in my loaded memory is the plan. And the reason for that is so that I can do things like edit it without thinking about it too much, and then just dump that into the file, and then next time the game runs, load that back up. Now, that obviously means I also want a good way to back those up so that if the artists have a lot of data stored in there, we don't end up losing the data they've got. So we need really strong visualization tools to make and sort of backup system to make sure we keep that data as what the game is, how the game is built. We want to keep that pretty safe. So those are the things I want to think about. So what exactly would the manifest data look like is my next question. So for that, what we want to do is look at this renderer compilation unit real quick and see if this is the side where I want to store that. This is the side that has right now functions like bind, BMP, and so on. That's in render target CPP. Bind BMP. Yeah, so here's where all the bind functions live right now. And I think what I kind of want to do is separate out binding from loading. So right now I bind these things and that causes the load. What I actually want to do is be able to bind things and store that in a data structure and then just say load the data structure, right? And that way the binding doesn't need to be a callback through the system either. So there's a number of things in there. And the first thing I think I should do is just try to separate out bitmap binding from bitmap loading. Luckily I already have that function pulled out, but let me go ahead and say that we're going to go a step further and say when I say bind bitmap, I don't want to bind it here, right? I just want to store that somewhere else. So that's more like this is causing a store to happen. And what we don't have right now is the render target doesn't have any kind of manifest setup. Render target setup. Font, image, render target. Okay, so here's where I'm going to put the asset manifest. And again, that just sort of needs to be a thing that allows me to take an ID and store that with a file name so that I know how to get that file later. Which means I need sort of a free list allocation scheme for identifiers and okay, I got some ideas. So what we need here is like an asset node, as I'm going to call it, and that's going to have a next and previous. And notice I'm storing these as integers, not as pointers for a particular reason. If I'm going to dump this to a file and load it back, I kind of don't want to use pointers with anywhere in this data structure, because that would, the only way to make that permanently correct is to either fix up on the pointers or to always explicitly base the data structure. And it seems to me like it'll just be easier to just do the slightly more higher friction thing of using integers everywhere and not trying to do any of those tricks. So an asset node will just have a next and a previous like that, and then we'll have some nodes. I'll just make it a fixed width for now, right? And in the future, what we might do is say, oh, we're going to need that to be growable. or something like this. Now, the whole asset system should be built on one big partition, but we can't use the standard partition if it's got a pointer in it. The only thing we could do is say whenever we reload the manifest, we're going to say grab everything like rebase the partition struct, and nothing else will have a pointer. So having one rebase at each reload isn't really a problem. And let's see, that would keep the position. That would mean we wouldn't be fixed into a real max, because anytime we ran out of memory we could just reallocate the whole thing and copy over, and then the file can of course grow indefinitely too. Yeah, so I'll do that. So there's just how we're going to allocate memory for that. And I'll actually just go ahead and say right away that that means that this here, again, I can't use pointers, but I'd love to use pointers. I could just store like I32 first node byte, right? But then it seems kind of like I'm gonna need, so okay, I'm just gonna do something maybe kind of wacky here. Position max. Alright. Relative partition. Now, where is my partition stored? Is that... oh, cd dot h part... no. Alright, let me look at the compilation unit real quick. Defines intern standard types system cd partition. There it is. Alright, I'm going to add a new type of partition. I'll just drop it right here, which will be very similar to a normal partition, except that it doesn't have its base built into it. You have to pass the base in everywhere. So you would have like relative partition, make relative partition size. Whoops. And there we go. We won't need you. And U should be a relative partition, right? So then I say here's max, position, blah, 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 blah. Cool. And then if I, let me get this cursor out of the way. If I want to clear a partition, that's the same as if I want to clear a relative partition. If I want to push a partition in, okay, so if I use a relative partition, the thing is I also have to include the base from outside, is the idea here. So putter equals base plus the position, increase the position, but the rest of the logic is exactly the same. Now what I can do here is start to say, alright, let's break the rules a little bit and try a trick. Okay. That's fine. Hey, Cuber Caleb. Watch this in case it gets annoying. 3 strikes and you're out. Alright. And let's see, we're gonna push onto the partition. Okay, so yeah, if I have push relative partition here, that does this work. Push partition of this kind is just partition star part. Yeah, so all of this is just a matter of doing return, then the call to the relative version with this guy's base, right? And alignment should always be a power of 2. That can be a relative partition, since that can happen without knowing what the base is. Sub partition. Do I need to know the base for this to happen? Okay, so what sub partition here, I'm gonna leave that because I don't know that I need that yet. Yeah, I'm gonna leave that for now. The thing that's difficult about that is, man, okay, like I just got a whole new host of ideas of what you would want to do to make a cool language feature. Is like, I don't really want this to be an inheritance-based solution. What I really want is to say that you can pass there's one type called a partition, but sometimes it's like a loosely coupled data structure where I actually can either pass it as this or the looser version with this and the separate void pointer, but then sometimes I don't include the void pointer and either of them can come in. Anyway, so yeah, the partition here is kind of annoying because I would also want to make like a sub-partition with a relative partition and a base at that time, but I would also want the ability to make relative partitions, and it's not clear if I would want to make those from both types or not. It seems like maybe I would. Okay, so it's not too hard to, whoops, go away. It's not too hard to make this do what I want. So just switch that to that and switch that to that. The result will be a partition. I take that partition, align it to 8, and the result's base is the result of pushing onto this partition with that base. If we got a base, then result max equals size, and we return. And then we can do sub-partition of a normal partition size, and then that's just sub-partition part base size, right? And then if I want to do the same things again, but in order to create relative partitions, what would that look like? That would be going like this, going like that, and we actually don't care about the base, so we don't need 2 functions now. And what we do is we take the relative partition, we align the incoming relative partition. We don't actually need a base at all, which is interesting. But we have to call push partition, which I guess isn't a problem. We can always call push partition with no base if we want to just reserve memory and without ever knowing what that will be based at later, which is kind of cool. So part 0 size, and then if we successfully push onto that partition, it'll give us something other than a 0 here, and we'll set this to have a max that works. Fucon, not only am I and Sean and Ginger Bill streaming, there's also William Chur, the Manifold Garden guy, is streaming right now. The question is, why aren't you streaming? That's the real question. Why is there anyone in my chat? Everyone should be streaming. Oh well. So let's see. That creates a relative partition from a relative or a normal partition, because we don't care about the base in that case. And this creates a partition from a relative or non-relative partition. Cool, cool, cool. Those will now just work for any type. Temporary memory. Temporary memory just needs a relative partition. Relative partition. Fucon will stream a ton when the summer vacation starts. That is good news. Alright. So now we can do temp memories on either type, which is good. And part malloc. Push partition. Yeah, so that has to be a real partition, not a relative. Okay, so now, that's good stuff. I need to switch. Well, first of all, do we still build? Huh. Alright, cool. So those are fine. So we have here now is, I need to get back to the render target header where I was working on stuff when I realized I needed a relative partition in the first place. Okay, so the point is now I have a relative partition which doesn't care where it's based, and I will be able to push on that and use integers as my pointers everywhere, which is what I want. And do you know what I should do? Do you know what would be really good? Yeah, I feel like this is a good day. This has turned out to be one of my good days where I come up with good ideas that make me better at programming. Now, where are my types? Okay, clearly that's not the one I wanted. Intrin? No. Defines? There it is. So I want to add a new one in here that I'll call let's see, like it's an i32, and I'll have a 64-bit version as well, which is like a relative putter 32 and a relative putter 64. Alright, so all of these i32s are actually relative putter 32s. Maybe I'll call those R putters for short. Alright, so now we've got asset nodes, and we've got the first node byte. So there's our array of all nodes. So we'll call this just asset nodes. And then I need an rputter 32 for, or actually what I need is an asset node used sentinel and a free sentinel. Alright, so we've got sentinels, and there's a thing if we just want to iterate all nodes no matter what. I need an asset node count, And this right here makes up my asset node list structure. Right. So now I can just grab an asset node whenever I need to, and well, I will be able to now that the data structure. I'm sort of thinking at a high level here. It'd be really cool if you just like type the data structure and then it like knows the algorithms you have in mind, and just spits out your copy of those algorithms or something. I'll think about that later. So, I've got all my use nodes, my free nodes, so I can grab a free node. If there's no free nodes left, then I'll need to extend the whole system then, which is fine. And then each node, in addition to all of this, needs to store a name and an ID, right? No, yes. Well, its ID will just be equal to its offset, right? Okay, so the third node, for instance, is with ID 3, but I'm going to store the IDs in there. Okay, so we're going to do, when I do image ID, right, okay, so we're going to call this image ID, and really what I have here is I have a couple of these. Whoops, did not want that to happen. Target H. Okay, so here is an asset bank, right? And then I'm going to have a couple of asset node banks, one for images, one for fonts, and probably eventually one for audio sound effects and one for music eventually. But we'll start by getting these ones built up. Now, each of those knows where the asset nodes begin and how many asset nodes. So I'm gonna do like asset manifest here, loaded assets there, right? And so we know how many nodes we have loaded, and we know where they start, so we know the whole size of the whole thing, and we don't have any way of seeing, so we want to know asset free count. How many more can we allocate here? Do we, or will we need more? And then what I want is I need to deal with this thing with the name, right? So each of these asset nodes currently has an image ID built in. So I also need an rputter 32. I'm not used to typing that yet. rputter. It's not actually that bad to type. No, okay. rputter 32 of the name, right? So that points to a null terminated name string, and that name is just a file name that's literally the full path to the file, or something like that. Now, here's the question: do I want a pointer to some name stored elsewhere, or do I want instead just like name 256 or something like this, right? And the difference, the reason it's important to get that right is if you go with this one, it makes your life a lot easier. But then if you have many strings, then every node, if this length of string, if the length of these names differs a lot, then you waste a lot of namespace. I feel like since this is a first, I feel like I'm okay right now with building this in. I'm almost always okay with building it in right off the bat because it'll make so many other things easier, and then if I need a string pool later, that won't be too hard to transition to, I don't think. um, I would just make a string pool that would become a part of the manifest system. It'd be built out of these R putters and things like this, and um, uh, yeah, okay. So I'm now at a point where I feel like this is a totally separate concept already, but I'm gonna leave it here for now because I gotta build it out in a slightly step-by-step way. So um, I need the ability to initialize, and yeah, I'm ready to pull this out into its own file. Okay, asset manifest.h. Um, okay, so we have nodes have a name and an image ID. Now here's a question. Will I be able to make pointers to the used and free sentinel? I think I will, because those will just be relative to the base. This whole thing operates on one base. So the whole system has one base pointer, and they all just have rputter32. So you can really have pointers into anything in there. It's just that all the pointers stored there have to be pointing to something in that block, and they have to use relative pointers, not real pointers. And other than that, it seems fine. So I can have that point at this and vice versa. And then the other thing you can do is, since we're not using normal pointers, we can decouple that if we want. I'm going to leave it for now just because that makes life harder. Okay, so, we have the ability to partition out memory here. And then we have the ability to give create these two banks, which will then be all we need. So now I just need to do the operations. I need to write the operations that operate on this system. So we need the asset manifest.cpp. And let me, before I get too far here, I'm going to take a moment and write usage code first. Namely, what I want to do is say, do I think I'll just get away with, oops. Come on, there we go. Keep hitting the wrong key combos. What do I think I'd get away with here? So I think that the code would look something like, you know, I'm in if not init, then the init gets set to true, and then it'll be something like vars asset manifest. I want to initialize manifest, and I need to give it a base pointer when I do that. So empty manifest. Yeah, okay, so I need to initialize an empty manifest, and really what this is more like is if it'll be like if not manifest file exists, then we'll do this. Else I see, so I just need to give it a size like, oh, you get k bytes. Now let's think of a good number of k bytes to give it. Right now I've got 16 images, and I want those 16 images to be each, let's see, 256 plus 4 plus 4 plus 4, so 4288. And then I need a little bit more for a couple of for about 4 sentinels and 12 more bytes and stuff. So if I gave myself 8K, I'd have plenty, right? So do something like this. Initialize you to an empty manifest with 8 kilobytes, right? And the trick is the asset manifest actually where I want that to be is I have like more like asset memory, and I just cast this to an asset manifest right here. I say you are an asset manifest, so do your thing, and then it'll go off. And now if I've already initialized, then instead of initializing an empty manifest, what I want to do is I want to say initialize the manifest, something like, oh, and this needs to also be vars asset memory equals push block on the normal partition, push the 8 kilobytes right away, and then pass that memory and the k bytes in like that. So we'll do it that way. And then here it'll be take a look at something like manifest size, and we'll just manifest file size and then I will push that much memory on to the big one, and of course what I'll do is I'll say we want to do something like manifest size equals, let's round that up to something a little bigger, so let's take k bytes 8, we'll round by amounts of k bytes, let's take that minus 1 and let's do that plus that, and the bit not of this number again. There we go. So that rounds us up to 8 kilobytes. And of course, while we're at it, we could double the size of that even, right? So that if we need more memory, we can just ask for it. Images. Alright, so then what this looks like is more like we get that asset memory, and then we literally just want to read that out, right? Well, what we could do to be even better is we read the manifest size and don't touch it at all. We push that on, and then we just do, like, mem copy into that from the asset file data manifest size, right? Something like this. Now these manifest file functions are kind of pretend, they're not quite real, but that's roughly the idea. Manifest file size, manifest file data, and the manifest file exists thing basically makes sense. So I need the ability to initialize something to empty, and then I need the ability to here, well, actually I don't need to support that at all. That'll just literally pull the memory back out as it was before. Which means this here will just return the max of the relative partition of the asset manifest, right? Okay, so that's what I want my interface to support for initialization. I also need to be able to do, if this is the first time initializing, I'm going to like bind image, here's the asset memory, and actually let's change asset memory to manifest memory. And then I want to bind the image, and then I've got like a bitmap and an ID, and I'll do that for a couple things, right? It'll be like, oh, here's all these asteroids. They get bound to these asteroid IDs, and so on, right? And then that name will just get copied into the name block there. For now, anyway. And then it'll know how to find that file, and it'll have it associated to an ID. So the other thing we need to do is say, well, yeah, this will just be a temporary measure. Once I've initialized the empty version, I'm really actually going to we're going to say that if the manifest does not exist, we have like a bug, right? And this code is really just to transition from where we are to generating the data we need, and then from then on we won't use this path really ever, which is kind of a unique situation. But I think that's the right way to get there, so that's what I'm going to do. One sec. It's getting too windy to have the window open. Alright, and I'm back. Now, that means I want to implement bind image and initialize empty manifest so far. Later on, the game will be going and we'll be like in the middle of dev stuff. Dev code, right? And then I'll want to be able to do stuff like if got file drop, then what I want to do is like, or like file drop, I can't remember exactly how this works, but something like if I got a file drop, then I want to be able to replace an image, and then I need to do that in the manifest memory. And I need to say, here is your file, the name of the file drop, and here is the ID that we, it'll be like something like ID image ID equals figure out ID to replace image ID, right? And it'll be the job of this code here to actually figure out which ID we're replacing based on whatever UI elements the drop interacted with. But when we do the drop, it'll interact with that element, figure out what the ID should be, and then tell us, and then we have to tell the system, hey, we're replacing this ID with this new name. It could also be that we do something like int action equals figure out action, and if that action is replace, we do this. But it could also be that that action is I should go close the other window in the other room. It seems like it's coming all the way through here, I think. It might not be a replace, it might be new asset. Right, so I have like new asset and replace asset here, and if I get an action that's a new asset, I need to be able to do int or just like add new image or new image blah blah blah. Now the problem here is going to be that if I do that, then the manifest might be out of nodes for that type. So I need to be able to do something like manifest expand result equals that, and then what I'll do is while result equals maybe that's an int, I don't know. Yeah, while result equals need memory, then we need some way to say like new memory equals get bigger block, and then we need to be able to do move to bigger block, and here's the new memory, here's the old memory, right? So that's like move manifest to bigger block, and it needs to know the size of that bigger block, so it's like size int size equals decide new size, something like that. And then we'll say here's the destination with this much size, here's the, I'll put this at the front since we always put that as the first sort of argument. Here's the old one, here's the new one, and here's its size. That should move that in there, and then we can do free this stuff, and that just goes to the sort of controlling memory management system, so that's not up to the API. But then move manifest to a bigger block, we free the old thing, and then we can set the manifest memory equal to the new memory. And that should hopefully then continue to work. So what I actually want here is like if, because I don't see me getting another result there. No, I see. So that's while result equals that. We do all this work, so that does like the grow the thing, and then we do result equals new image. We try to put a new image into the manifest again. Right, because the first time through it didn't work. File drop image ID. Actually, we don't. When we're giving it a new image, we won't give it an image ID. We'll just say there you go. And so now we can add a new image. We get a result. And that might be a success code or a need memory code and so on. And once I've got a new image in the system, what do I need to be able to immediately get the ID for that? I don't think so. I just trust it has an ID now, and yeah, that seems fine. The other cool thing about this is even though they have IDs, the ordering can be set up by the nodes. So if they want to reorganize things so that it's like, oh, I want these things to be ordered this way, that's just a matter of reordering them. I also think I want to have a hierarchy. So like I said, I want to be able to have like, there's the asteroid set, and the set is just like, oh, you can put more asteroids in there, and it expands the pool of possible assets that get used to represent asteroids. So that would imply we need some kind of hierarchy of a node maybe is in this linked list, but it also knows where its children are somehow and stuff like that. Or maybe, the parent would need to be able to query its children pretty quickly. So yeah, that's some interesting stuff to think about. I'll think about that in the future. For now, these are the operations I think I need to support. I need to support initialize empty manifest, manifest memory int size. I need to support bind image, manifest memory, file name, image ID. I need to support just think about something. But it doesn't look like it goes the right direction. So, anyway, replace image, I need to support. Replace image, so I supply the manifest memory and a new file name and a new image ID. And then I need new image, manifest memory char star file name, and then I need, that is actually got to return some kind of result, and then I need move manifest to bigger block. And that gets the manifest memory, the new memory, and the size of that new memory. Alright, so I'm going to be right back in just a few minutes. I have to go check that other window, make sure it's closed so it's not blowing stuff around, and maybe use the bathroom, and then I'll be back. And I'm back. Okay, so these are some pretty interesting operations. So first of all, to initialize an empty manifest, I believe what I want to do, and this is not necessarily already set up the best way possible, but there's not going to be that many fonts, and I don't think that the font selection is going to grow very often. Which means I kind of want actually, eventually what I should do is just plan on, okay, I'm going to only run images through this right now, and in the future I'm going to plan on fonts just being another type of hierarchy thing where I have a font node that has a bunch of children for its glyphs as images. That way I don't have to think about that. And now I just have this one node bank right now. I still think I need another node bank maybe in the future, although not having more than one node bank would make life easier. I'll just leave that alone for now, and we'll see in the future, I guess. Let me put the dates on these real quick. There we go. Okay, so now initialize an empty manifest. That involves going asset manifest. Here's the manifest. Is just the asset manifest pointer version of the manifest memory, and the manifest part just needs to be make relative partition out of that size there, and then we want to push up onto the we want to push a struct on there right away um, manifest memory, asset manifest, right? And the reason we do that is because wait a minute, push struct, I see an issue. So let me go back to the partition real quick. So when I push a block or something, yeah, I don't pass that comma along. So I have push type. I can still push a block. I don't actually have push struct as even a thing. It's push type. But the problem is this macro is only going to take a p and a type, and then it's going to push partition there. But I wish I could overload that macro so that I could give it a p, a type, and like a base, or a p and a base. But that's not going to happen. So here's what I actually need. Here's my only other option, I think, is I can make a sort of wrapped partition, which is going to be a pointer to a relative part, and then a base pointer, right? And now what I need to do is say yeah, in order to make one of these, wrapped partition, make wrapped partition. All I do is I give it a relative partition and a base. So this is a way of temporarily saying this relative partition is going to operate with this base, and then everywhere it goes, it will use those together, so the macro will work mostly. So yeah, wrapped partition, wrapped is, let's do it that way, wrapped dot rel part equals part, wrapped dot base equals base, return wrapped, push a partition, wrapped partition part, I32 size, oops, is the same as push partition part rel part base size, line partition is the same as wrapped, for a wrapped partition is the same as aligning the partition for the relative part with the same exact parameter. Leave this for now. And then the point is I should, if push partition will work, yeah, so now those macros should wrap that correctly. And maybe I want a temp memory here as well. I give it a wrapped memory, a wrapped partition. It just needs to get the relative part of that partition, I guess. Okay. 37. What's going wrong here? Partition, temp part, position, 251. How is that? Okay, render target CPP 251. I see. So yes, we're just going to leave you the way you are. And now I'm going to switch over to the asset manifest CPP again. Make this my big window. And now what I plan to do is we make the relative partition. We want to push a type on it. To do that, what we're going to need is a wrapped partition, which will be our partition for now on. Make wrapped partition. That goes around the manifest part with this as the base. Interesting thought. What you could do is say that you don't need this because you'll just make a rule that the pointer to the partition is always the base of the memory, right? As in the relative partition is always stored at the first byte of its base. But I think I don't like that, because the advantage to that is that it simplifies some of that interface. The downside is that it couples the memory base to the relative partition now, and it might just really be not directly couples them. You're still able to move the base around as long as you copy it all, but now you can't have a relative partition that isn't positioned in that exact position relative to its memory base, basically, right? So there's kind of there's no other place you can, once you know you want some partition in some memory and you want it to be a relative memory, you have to put a relative partition at the very first byte. You can only make sub-partitions of that by putting a relative partition right there. There's never a way to like have a copy of the partition somewhere else and operate through it or anything. So I think I'll stay away from that, but it's a possibility. So now I've got that, and I can do push type onto that part, the asset manifest. And the reason I do that is just to mark that that first struct has actually been consumed in the memory already, right? If I come back here, now the next thing I need to do is I need to initialize this asset bank a little bit. And the way that needs to happen is that I need I need the manifests images dot asset nodes to equal and then what I'll do is I'll push an array onto the partition of asset nodes with a number which is going to be whatever's basically left in the partition divided by the size of that node, right? So node count. And we'll set node count equal to partition, let's see, a manifest part dot max minus manifest part dot position divided by the size of an asset node. Okay, so that gives me a node count. and then I push that on there, but that's returning to me a pointer, right? I don't actually want to store a pointer there, so what I'll do is I'll say the asset node goes right here, and what I really need is like to rputter kind of call here where I can put in a pointer and the base pointer, and then it'll do that and vice versa. So let me add that up here. I need a rputter32. I'll call this to rputter32 in case I ever do 64-bit versions. And I take position and base, and then I do rputter32 result equals position minus base return result. And I'm also going to want to putter, which will return a pointer given an rputter result base plus the position gives you the pointer back. Okay. So those will be nice to have sitting around. I'll just inline those real quick. There we go. So now I grab that array of nodes, and then I pass it in here to get the exact pointer difference between them, and store that as the asset nodes rputter. Now I can also set the manifest's image node count to be node count, as well as the free count. And then what I want to do is I want to do init sentinel manifest images dot use sentinel. Here's the manifest memory you're probably gonna need, and init the free sentinel. So that inits the sentinels, and then I can do for I equals 0 to node count plus plus I insert node and basically that's going to be a node that starts at the beginning of the nodes and traverses them, and it's going to be inserted. I want to insert it onto the free node, or the free sentinel, and here is that base again. Okay, so now I need to make those helpers real quick. I've got init sentinel, which takes an asset node and the base pointer, and it says, okay, node, so your next needs to be self, and your previous needs to be self, and self needs to be whatever we get when we take this. And then insert node will take a pair of node pointers and the base and say, okay, so here are the people involved, right? There is there's node which is to rputter32. I'll call that node self. Node base. We're going to need to know the position self, which is base. we're going to need to know, let's see, during the insert we need to link you to there, you to there, and then I need to link you. So I need to know the position next, which is going to be just position next, like so, right? But I'm also going to need to know the asset node next, which I get by doing asset node pointer to putter on position next from base. Okay, so that creates I now have access to the 3 nodes involved, both in terms of. So this is going to be the next self, actually, both in terms of their sort of rputter values and their addresses, their memory addresses. So now, nodes previous equals position self, node next equals next self, positions next equals node self, and next previous equals node self. There we go. So that should do an insert. While I'm at it, let's go ahead and do a remove node, because we're going to need that. Asset node, and it's going to need the base. And to do that, we need to know rputter 32 next self equals to rputter 32 node next base previous self node previous base asset node next equals asset node to putter next self base prev self base. So there we go. And then next previous needs to equal prev self, and prev's next needs to equal next self. That's all that needs to happen there. Great. So now, oh, do you know, there's another one I need. If I'm going to have new images, I'm probably going to also want to be able to say, delete image, manifest memory, int image ID. Okay, so now I believe that is done initializing everything except what do I want to do about the image ID there? I think I want to just set all of the nodes image IDs whenever I create them and leave them there forever. So let me actually reposition that like so, and do for each of those nodes, set the image ID equal to I plus 1. Okay, and the name will get set when it needs to get set. So they each have a next previous as set by the insert node. They're being chained onto the free sentinel, and the image ID is set, so that's all initialized. These two got initialized, those two got initialized, that got initialized, and that. Okay, so there we go. Initialization complete. What about binding an image to an ID? And what I want to do here is actually say, since this is a specific, like it's not, this is specifically saying I want this ID to this image. But it's basically the same as replace, except saying don't trigger, don't actually throw an old thing out if there's already something there. Bind only wants to say if the spot is available, do the binding. Otherwise, return failure to me, is what I think it wants to say. Right. And then, beyond that, what it needs to do is, and technically, replace image could also fail if the image ID is wildly wrong or something. So I'm gonna just say that these have some failure cases, and we're good. So, when I go to bind an image, if there's a file name, image ID coming at me, then what I want to do, and this is where maybe what I should do is say, when I have that node, I'll set the name 0 to 0 if it's free, and then right here I can just go in a few steps. We need to get the asset manifest. Manifest equals asset manifest memory. We need a wrapped partition. No, we don't even need that. What do we need? We get the manifest, blah blah blah. What do? I want the manifests asset, so I want the nodes basically. I want the asset node nodes, which is going to be asset node to putter the manifests image dot asset nodes from the manifest memory as the base, and then I want nodes plus image ID -1, and that gives me the node I actually care about. And then what I want is if node name 0 equals 0, then we have an unused node. And really that means that we have to make sure that file name 0 does not equal 0 to do this, because that'll just be confusing. If you give me an empty string, then I'm not binding you. Sorry. Okay, so if the name is free, then what I'll try to do is say, okay, let us remove that node like so. Let us insert that node manifest images used sentinel with that base. So insert that there. And that doesn't change the image ID, just moves next and previous around, and then it then we need to set the name. So then we just do stir. Oh, well, the other thing I should do is say, let's get the len up here, right? So we're gonna have a len of 0, and what we could just do is say len equals stir len the file name, and we want that len does not equal 0, and len is less than asset max name 256, asset max name, asset max name, right? So now I'm doing that. The only thing I want to change is switch that to cd strlen and come over here. And that we will just do as boom while something like that. Yes. And then return s minus b, right? Yeah. So that gives me a strlen that's nice and straightforward. And then if the len is not in range, we ignore it. Otherwise, we come down here and we will mem copy into the node's name from file name with len plus 1 bytes. And that means I need mem copy dist source size. And that's just a matter of well, you know, it looks like for now I'll just mem copy those directly, and some other time we'll get around, because it looks like memset's doing the same thing. So for now I'm just putting those in so that I can pull them apart later, I guess. Okay, so then I do the mem copy, and while I'm over there, I'll just go ahead and make this happen. Alright, now I've got a copy of the name stored in the node. So I think the binding has occurred at that point, and I can set result equals 1. Right? So that performs an initial binding. Let's see how we're doing. Compiler bugs, or compiler errors. Alright, there we go. That's a fairly long build time. I wonder if that's just the stream inflating that, but even without the stream, I bet that's like 3 seconds. I'm curious about why that is. It's 3 modules. 4coder is also 3 modules. I wonder if it's this thing having to link. Having to link that might be a problem. I should see if I can find a way to inline it. It's going to be tough. Okay. Replace image. So the big difference here is that if I replace an image, if I call replace image, I want to fail if the image is not loaded, right? If the image was free before, then that means replace. So really, I only want to do this. I want to do the same thing except not equals here, right? So I'm going to first copy paste the code, and then I'll think about a way to get rid of the redundancy. So literally, this one would be that. So what I'm talking about actually having is more like declare image, manifest memory, file name, image ID, and then all of this. But then an extra additional parameter that says int expect empty. If that and you expect empty, or if not this and you do not expect empty, and then these just become return declare image manifest memory file name image ID true and false, right? Okay, so now this one, new image is a little different. It's basically a matter of try to get an index if there's see if there's an available one, try to get it off the free list and then bind it, right? So we're going to do sort of a similar initial setup. Well, first of all, we can do like all of this, except this one here will have to be different. Alright, how does this need to work? Let me look at the manifest. What I want to do is I want to get the images dot free sentinel dot next output from that, and I want to store that in an asset node. And then I want to do if that node does not equal free sentinel, assert that that node name 0 equals 0, and then do so this would be kind of like a copy of all of this. So what I really want is something more like use node int, no, void use node does all these things, and so this guy down here also just uses the node and results in 1. But now, what parameters does useNode need? It needs to know which node it's going to use. It needs to know about the we'll call that the base. It needs to know about the file name and the len. Manifest images used sentinel. Yes, and it needs to know the used sentinel. So we'll do 3 layers there. Oops, there we go. We remove the node, we insert it into the use area, and then we mem copy the file name. So all together, that is, we give it a node, we give it an manifest images used sentinel, we give it a file name len, and we give it the manifest memory. And you down there will be exactly the same. Yeah, asset and assert are a bit annoying when you're dealing with this code. I only have one assert so far. Right there. Okay, so now new image is pretty clearly just a matter of try to get an image off of the free sentinel, and if we try to get a node off of the free sentinel, and if we succeed, um, just double check first of all that the node is actually free, otherwise it'll crash. It's an assert, and then try to use that node the same way as if we had explicitly asked for that node up here. And we return 1 if we succeed in getting the node. So now delete image. So that is again kind of gonna start like this, but it's gonna be a little different because what I actually do is I get the nodes and I two-putter the manifest images asset nodes, right? And then I've got the nodes as that, and then I can do asset node equals nodes plus image ID minus 1. Now I've got the node I care about, and next I want to make sure that that node is in fact not free, and then I'm going to do use node. No. I'm just going to do remove node. No, yeah, I'll use node. Use that node, but now put it into the free sentinel. Give it the name like that. And here's the manifest memory. And then I'm going to rename that from use node to update node. Alright. Still some kind of forecoder bug there that I don't totally understand, that only shows up sometimes. Okay, and never the times when I'm trying to find it. Maybe it's like a frame thing? Let me try that. Replace void with int begin. We don't see it yet. Yeah, that's not enough. Why does it not show up on the first one? I don't know. Okay, now this is the big interesting one. Move the manifest to a bigger block. Now, the trick here is really right now all I've got is one big chunk of nodes, and that might be good. I might want to keep it that way because that makes it easy to expand this. All I have to do to expand it is allocate a bunch of new nodes, mark them all as free, and give them all their IDs and insert them into the free node, right? Then I've got into the free sentinel. Then I've got a bunch of new free nodes that I didn't have before. And other than that, it's just a matter of copy pasting all of the data out of the old block and into the new block. Everything before, all the addresses there relatively line up perfectly there, so you just copy paste and then allocate new stuff and put them on the free list. So let's do that. Memcopy into the new memory from the manifest memory. How much, you ask? Good question. Hadn't thought that far ahead, but that's okay. The asset manifest memory manifest part max, right? So we just grab all of it. We don't care if some of it's not useful memory, if there's a chunk at the end that's not being used or anything. We just say if we're moving to a bigger block for any reason, just copy all the memory. That's the easy way to do it. And then we just need to allocate a new chunk. So let me take the wrapped partition, and well, first of all, let me say that after we've done that, your max should now be this size here. We've now moved to something of that size, so that's your new max. And you know, let's assert, not there. Let's assert that manifest part max is strictly less than size. Don't shrink me, that'll just be annoying. So assert that we're growing here, and then we go ahead and do the copy, and then we go ahead and set the partition's new max. Then we can make a wrapped partition. Make that from the manifests partition and the manifest memory, and so that makes that partition wrapper, which I can get a pointer to, and then I want to get sort of a new node count equals, and this already has been done once before up here when we were doing this, right? So this and that code are going to be kind of duplicated with one another. Asset manifest.cpp. Yeah, so here we're initializing empty manifest. Down here we are getting a new node count, so it's the same concept though. We take the same thing, let's just call that the node count so that they match up. We figure out how many we're going to get, and what I should probably do is say, look, if this turned out to be greater than 0, then let's get the asset node, the nodes, and push an array onto that partition wrapper that we've got. An array of nodes with node count being the size of that array. And really we're just extending an existing array, extending an existing array there. And then let's see, so the init sentinels could happen beforehand, as could, well, what actually should happen is these should get set to 0 to begin with, and then they just get added in. And the reason those should get added in is because that's what the other one is going to do, right? This one over here wants to add those in as well. So we go, here's the new nodes. So asset nodes, actually, I take that back. Asset nodes just wants to get set once there, and then stay that way permanently. The other ones, though, will be node count plus equals that, free count plus equals that, perfect, and then finally I need to do this work here. So I grab a pointer to that node, and I iterate across all of these new nodes, and for each one I insert it into the free sentinel. I set its image ID. Now what this really needs to be is more like some kind of j plus 1, or just j even, where yeah, j should be stored up here as whatever my node count was before, plus 1, and then it'll get a plus plus j everywhere it goes. Okay, so now I can see that if I do something like whoops, that, then we can do the 2 output of 32 here. And the reason I'm doing that is the point is this should never happen during a move manifest a bigger block, but I'm seeing that these two blocks of code are so similar that I want to pull them out into one system. And so now I think we're ready to do that, and the way that'll go is void add free nodes, and the way that we'll do that will be revealed to us once we start. Now the node count is retrieved in the same way. This one over here would still work if we were doing the if node count equals or is greater than 0 part. That's good. It would still work if I did this. So that's good, right? And then I would do J, because we know asset node count starts off at 0. So that's basically going to give the exact same values as what I was giving before. We need to do a plus plus J there. So now those entirely match, except for that if, right? We need this, this if here to match. And yeah, that's doing the same stuff. If we assume that got initialized at 0, then there we go. And now what I'll do is I'll call all of that code there. Add free nodes. Right? And same thing with you. All you're doing there is a little matter of add free nodes. Now, we need to figure out the parameters of add free node. It looks like it needs a wrapped partition. Oh, it could just take the manifest, the asset manifest, which means we could just replace manifest memory with the manifest in this case. The node count comes out there. Then we need we do need a wrapped partition still, unless we're willing to do it manually again. Nah. So we use the wrapped partition. We get the array of nodes. We find out what the next image index is. We set the asset base if we haven't set that yet. We increment the number of nodes we have in both of those counters. We iterate over all of the new nodes, and we insert each one into the free list. We give it an ID, and we set its name to 0. Alright, so those look correct. So now I just need to pass in the manifest and the part, and what really I could do here is just simplify that, because that's all that's ever going to do. And then if I go up to this one, I'll give it the manifest and the part. Okay, and let's see, we got manifest, la la la. Okay, that seems pretty good to me. Of course, we'll see for sure when I see if I can compile it or not. But the other thing, there was one other thing on my mind. Add the free nodes. You push them all on there. They're all linked up. Ah, yes, the free count. So I'm not actually, when I do these things, incrementing and decrementing the free count correctly. So basically, whenever I go to update a node, if I'm moving it onto the used sentinel, I want to do manifest images dot asset free count gets decremented, right? So let's see, update node. Oh, I just noticed something. So if I'm expecting empty, then I want to do this, right? But if I'm not expecting empty, I actually don't want that. Right, then I'll just do like that, and we'll do update the node, don't move it anywhere, but still give it a file name len, and here's the manifest memory in case you need it somehow. So update node needs to be able to optionally not do any of this. If used sentinel, and I'll just actually change that to position. Alright, so now if I provide a position, it inserts me there. If I don't, it does no movement in my node, and then if I provide, we'll say if I've provided a file name, so we can just make both of those optional, which would be cool. And yes, okay. But this one, as I was saying, we need to update the manifests. I don't know if I have it on there. Images dot asset free count needs to get decreased, right? And whenever I create a new image, I also move on to the used sentinel. Then here I move on to the free sentinel. So I want to increase that number there. Whoops. Boop, boop. What do we just do? I don't want that there. Undo, undo. Do. Oops, do. Oh, that's wild. Is that a bug? Yeah, it totally is. Boop. Alright, so I should go fix that in 4Coder. Did you see what it was doing? So if I come over here and I do that, and then I go over to I'm on the right hand side. If I go Control plus, it writes that on the left hand side. It's crazy. Okay, and I know why that happened. It makes sense. But let me just get back to where I wanted to be. There we go. Okay, so now we're keeping the free count correct, and I believe we're moving the manifest block correctly. So now what I want to do is, just for now, I'm going to... It's not ready yet. All we did today was define a basic data structure for storing assets. And sort of the binding between files and asset IDs, actually. So it's not at all ready to do anything too fancy, but I can now say that in the vars up here, we can store an asset manifest, and that's false. We're going to store manifest memory, and that's in the dev vars, so still false. Here's app vars. There you go. And then right after I've established my target, I'm going to do vars manifest memory equals push block, and I'm going to give it 8 kbytes from my manifest memory, or from my logical memory. Is that what I want? Actually, no. From the trans part, I believe, is what I want. Yeah. So that gives me 8 kilobytes from the transient memory, and now the manifest memories exists. What I want to do is say, for now, I'll just always do empty initialization, since I don't have a manifest file set up yet. That's a different thing I actually have to set up separately. Initialize empty manifest. Here's the manifest memory. Here is the size of the manifest memory. manifest size, initialize the empty manifest, and now, while I'm doing this, I can also bind image on the manifest. I'll just call this manifest for now, and I'll have a little void pointer manifest equals vars manifest memory. Grab a manifest, bind it like so, background. Main target bind BMP becomes bind image, and setup becomes manifest. And that's it. That's literally the only changes I have to make. U2 main target bind BMP and setup becomes bind image manifest. Boom. Okay. So let me just see if the game runs still, or compiles, or whatever. Initialize empty manifest. Identifier not found. You're right. I have not done my job of including that. Include cd asset manifest cpp, and up here for now I'll drop it in right there. Manifest CDP. That explains why we never got compilation errors. This makes a lot more sense now. rputter 32, 35. Next equals to putter position next. You're right. Next self. 46. Next self to rputter 32. Cannot convert. Argument 1 from rputter 32. Oh, I've already got that as an rputter 32. I don't need to do this. Prev. Nodes equals, I grab the asset nodes. That all looks good. Images 156. CD Sterling. Undeclared identifier len. Man, that takes a while. It's weird. Okay. Bind image manifest Sheila BMP. There we go. Guess I haven't run this all day. Here we go. Alright, so the initialization didn't blow anything up. So hopefully we kind of sort of now have an asset manifest defined. And I'd like to see if I can on the fly edit it without crashing either. I don't see into it right now. Until I can see into it, I won't really have any reason to believe that it works. But if I call it and it crashes, then I know it doesn't work. So that's a first step. Right. So here I want to do replace image. We're going to take the vars manifest memory and we're going to replace it with this drops name, and we're going to replace this image ID. And again, that's just sort of hard-coded image IDs for now. Once I have the GUI up, now that we've got this asset system started, I can probably get a GUI up soon that will list the assets, and then I'll be able to hand pick which asset to replace. But for now, let me just pop this over here and find an asset folder. There we go. So here comes the blue ones. Boop. And yeah, that didn't seem to crash anything when I did that. Now if I do that a bunch of times, does anything go bad? I'm only doing 6 at a time. There might be a lot of these things, so let me just walk through it real quick to make sure it looks right, and I'll call that a day. A day of streaming anyway. File drops. Here it is. Incoming file drop. Alright, when it goes to replace an image, gets the length of the file name, which is well within that range, and then we come in here, and by the way, if I look at the images struct, we have 28 nodes and 12 of them used. Interesting. Interesting. So 8K gave me 28 nodes. Yeah. And that's partially because, look, like the file name took 36 bytes and I gave it 256 bytes. Eventually they're all just going to be in an archive, and so the names will be able to be really short. And I think at that point I'll just want it baked into the node, and I'll just drop down that size to the point that it'll be awesome. Having a bunch of extra like allocation work for strings seems like a mistake at that point. So I'm going to keep trying to just, let that work. Now, let's see. We did not expect empty, and the name did not start with 0. Now we're updating the node. And then result equals 1. Yeah, that looks fine. And they're all going to do the same. So yeah, now I have some data structure that's keeping track of, for each asset, the file it loaded to get that asset. And that's useful because that means I can do like iteration across all of the used assets, and then like for each one of those assets they become a drop target that I can drop an image onto, and that'll tell it, hey, update the, for this image ID, update the file that goes with that image ID, and other similar things. Like if you see that the file, this particular file has been saved again, then reload that asset and all that kind of cool stuff. So yes, that seems like a good direction to be going in. I also need to do the thing that drops it in and out of a file. So I think the first thing I want to do is make it editable, and then I'm going to make it so that it goes through a file. But that won't happen on stream. It might, maybe some of it will, but I'm not sure what portions will get done before stream, if not all of it, next week. But anyway, thank you anybody and everybody who came out to see the stream. I think that's it for today, so see you later. Bye.